Everyone, welcome to the session on Azure Data Engineering Ecosystem. By the end of the session, you will gain a clear understanding of each Azure data service from ingestion to analytics, along with real world examples, architecture diagrams, and an end to end project scenario. This walkthrough will also show how you can apply these concepts in practical environments, design scalable pipelines, and prepare for data engineering interviews or certification. So let's begin exploring the Azure data engineering landscape. We'll start with overview session. Azure data engineering is all about building reliable, scalable data pipelines that collect, process, and deliver data efficiently for analytical arm and decision making. In this section, we begin with simple yet powerful diagram showing the data engineering flow. You can see the journey starting from data source, moving through ingestion, storage, processing, and finally analytics. Each of these stages represent a major responsibility for a data engineer. Azure provides a complete ecosystem to handle every part of the flow, whether it's structured data from databases, semi-structured data from APIs, or unstructured data like logs and media files. Further down, we also cover why Azure is the preferred choice for enterprises. We highlight four core strengths, which is security, scalability, integration, and efficiency. Azure ensures enterprise grade compliance and offers seamless integration with more than 100 data sources, making it an ideal choice for end to end analytics solution. This overview sets the foundation for the deeper topics ahead. Next, we move into storage services, the backbone of any data architecture. This section introduces the Azure storage options that every data engineer should master. The first one is Azure Data Lake Storage Gen 2, a scalable, high performance data lake designed for big data analytics. It allows you to store massive amounts of raw and processed data in an hierarchical folder structure. You can store structured, semi structured, and unstructured data from JSON logs to image files. There is a practical example here of an e commerce company storing customer transactions, clickstream data, and media files in an organized folder hierarchy within ADLS Gen 2. This helps learners visualize how raw and processed layers are maintained in the real worlds. Next, we have Azure SQL Database, a fully managed relational database service. This is best suited for transactional applications and structured data sets. A healthcare system example is shown here, storing millions of patients' record, appointments, and medical inventory, emphasizing the need for ACID compliance and strong query capabilities. Finally, there is Azure Cosmos DBs, which is a globally distributed NoSQL database. It's optimized for low latency and massive scale. We use the example of a gaming platform where millions of players connected globally require sub to 10 milliseconds responses and 99.99% availability. We have a storage comparison table clearly summarizing each service's best use cases, supported data types, and scalable scale capacity, which helps learners quickly identify which tool fits which scenario. So here ADLS Gen 2 which supports any format of data type we can be used for big data analytics and scale. You can upload till petabytes, 1 PB, 2 PB, 3 PB. Coming to the SQL database, which have a data types of structured only, and it is for transactional apps and maximum of 4 TB of databases supported. Coming to the Cosmos DB, which supports JSON and documents data type, which is for global apps, and scale is for unlimited. Once data is stored, the next stage is processing. Once this section explores four of Azure's most essential data processing tool, each serving a unique purpose in the pipeline. First is Azure Databricks, an Apache Spark based platform for big data processing and machine learning. It's ideal for distributed ETL workloads, data transformation, and collaborative analytics. A retail analytics example demonstrates how a supermarket chain processes over a TB of data, daily sales data to generate insights within a minute, something that traditionally took hours. Next, Azure Stream Analytics, designed for real-time stream processing. For example, in smart manufacturing or IoT scenarios, data from thousands of sensors can be analyzed in real time to detect anomalies, trigger alerts, and prevent costly failures. Then comes to the Azure Data Factory, which is Azure's native ETL and orchestration service. This is where you schedule and automate your data pipelines. A banking example is provided here, showing nightly ETL jobs that extract and standardize data from multiple regional systems, apply business rules, and load it into a central warehouse using visual no code pipelines. Then we have Azure Synapse Analytics acts as a unified analytics engine combining traditional data warehousing with big data capabilities. The telecom example highlights querying 500 TB of call records in seconds, demonstrating how powerful distributed compute can be within Synapse. Together, these services form the processing backbone of Azure Data Engineering. Once processing is complete, it's time to derive insights. And that's where analytics and visualization comes in. This section covers with three main tools. First one is Power BI, Microsoft's visualization and business intelligence platform. It connects to data sources like Synapse and provide dynamic dashboards and reports. Here we have given an example to demonstrate how a sales director monitors performance in real time across different regions with auto refreshing dashboards. Then comes to Azure Machine Learning, which allows you to build, train, and deploy predictive models. The churn prediction example illustrates how a subscription based company uses machine learning to identify customers at a risk of cancellation and take proactive actions. Then comes to Azure Cognitive Services, which provides pre-built AI models for tasks like computer vision, speech recognition, and sentiment analysis. In this example of an insurance company, AI automates claims processing by extracting text from images, analyzing languages, and prioritizing cases, reducing manual efforts up to 70%. This section emphasizes that data engineering doesn't stop at pipelines, it extends into generating actionable business intelligence and enabling AI driven decisions. Then we are moving into real time example scenario. Here, we walk through an end-to-end example, a Netflix-style recommendation system built entirely on Azure. This scenario brings together every services you have learned so far in a one integrated solution. The step one is data ingestion. User activity data is streamed from mobile and web apps using Azure Event Hubs, handling over 100,000 events per second. So here we have a data source which is from mobile and web apps. Through Azure Event Hubs, it is sending views events. Then we have a user profile which is stored in Azure SQL database. Then video metadata is stored in Cosmos DB. Event track will be like video start, pass, complete, rating, search queries. So user ID will be 1235, which is from Azure SQL database. Video ID is 987, which is taken from Cosmos DB. And action is complete, which is event track. This one from Azure Event Hubs. Then coming to the step two, which is real-time processing. The Azure Stream Analytics identifies trending videos, detects anomalies, and sends live metrics to the dashboard. So, trending now. So, calculate most watched videos in the last 1 hour. Anomaly detection is detect buffering issues affecting greater than 5% of users. Live metrics, current concurrent viewers per region. The output will be updates Power BI dashboard every 5 seconds from the Azure Stream Analytics. Then step 3 will be our data storage, which we will be using Azure Data Lake Gen 2, which organizes the data in a bronze, silver, and gold layer structure, ensuring raw, process, and curated data are well managed. Then we are going to the step 4, which is batch processing. Azure Databricks performs nightly ETL job, which done with cleaning and aggregating terabytes of viewing data in under an hour. Then we are going into the step 5, which is a data warehousing. Azure Synapse Analytics hosts fact and dimension tables, enabling executive to query millions, billions of records instantly. Then we have a step 6, which is machine learning. Azure machine learning trains recommendation models using collaborative filtering techniques, improving user engagement by over 30%. We have a step 7, which is visualization. Power BI provides dashboards that track active users, subscription revenue, churn predictions, and regional performance. Finally, there is a summarized architecture diagram connecting all devices from event hubs through stream analytics, then data lakes, then we have a Databricks, then Synapse, then we have a Power BI, then Azure ML. A cost estimation is also included, giving learners a sense of real world cloud expenses. Even the hubs will be cost for $500 for a standard tier. ADLS Gen 2 is for $1,800 for 100 TB storage. Databricks, which is cost $3,000 for nightly processing. Synapse will be like approx $2,500 for 8 hours a day. Azure ML for training plus deployment for $800, which will cost roughly $8,600 per month for processing 2 TB data daily. So next section comes to the quiz. So storage section selection. A social media company needs to store 10 billion billions daily users posts JSON format for analytics. Which service should they use? So we have Azure Data Lake Storage Gen 2, Azure SQL Database, and Azure Blob Storage. We'll be using Azure Data Lake Storage Gen 2. So an IoT system has 10,000 sensors sending temperature data every second, which service process in real time. So real time is Azure Stream Analytics. So you need to schedule a daily job that copies data from 20 databases, transforms it, and loads into a warehouse. Which tool we'll be using as a ETL daily job? We'll be using Azure Data Factory. A retail company needs to process 5 TB of data, of sales data daily using distributed computing. Which service will be using? We'll be using Azure Databricks. A gaming app needs less than 10 milliseconds response time for millions of users worldwide. Which database will be used? Gaming platform will be using Azure Cosmos DB. So your score is 5 of 5. Perfect. You are ready to build Azure data pipelines. So to summarize, as a complete foundation for mastering Azure data engineering, it's not theoretical, it's practical, visual, and scenario driven. We covered every layer: storage, processing, analytics, and machine learning with real world examples and architecture illustration. I encourage you to explore each section carefully, take notes, and use the examples to design your own Azure data pipeline. Thanks for Thank you for joining this walkthrough of the Azure Data Engineering Ecosystem. Continue learning, keep experimenting with Azure services, and prepare to build real enterprise grade data engineering solutions. Thank you.